We humans, we think we're the planet's greatest inventors. The microchip, the jet engine, the skyscraper. But we're not. We're just good students. At best, we're thieves. Because our best ideas, we stole them. We stole the secret to a sunlight-readable screen from a butterfly. We stole the design for a painless needle from a mosquito. We stole the secret of ultra-efficient light from a firefly. And we stole the blueprint for natural air conditioning from a termite. But this isn't theft. It's an apprenticeship. And our mentor is 3.8 billion years old. This is biomimicry. It's built on one simple, profound idea. The world around us is a 3.8 billion-year-old research and development lab. Every living organism today, every leaf, shell, and wing is a survivor. A high-stakes experiment that has already solved nature's hardest problems. How to find water in a desert. How to stay cool in the sun. How to build without waste. Biomimicry changes the question. Instead of asking, what can we take from nature? We ask, what can we learn from it? And we learn at 3 levels. We can copy form, the shape. We can copy process, the method. Or we can copy system, how everything works together. Today, let's meet 5 insect geniuses who've already mastered all 3. Invention number 1. The firefly's lantern. Let's start with form. Our best LED lights are only about 50% efficient. Not because they don't make enough light, but because they can't get it out. Much of it gets trapped inside by internal reflection. The firefly, which needs to shine as bright as possible to attract a mate, solved this problem millions of years ago. Under a microscope, its lantern isn't smooth at all. It's a jagged, uneven mountain range, a chaotic landscape at the nanoscale. Researchers at Penn State and in Belgium found that these tiny asymmetric microstructures act as the perfect anti-reflection layer, guiding the light outward. When scientists copied that exact pattern onto an LED lens, the result was a light that was 55% more efficient. The lesson? Nature shows us that smarter structure is often more powerful than just more energy. Invention number 2. The butterfly's wing. Here's another challenge, also about form. Your smartphone screen is a power-hungry vampire. And the brighter the sun, the harder it is to see. But the Morpho butterfly's wing does the exact opposite. That dazzling, impossible blue isn't pigment, it's structural color. Each scale on its wing is a microscopic forest of ridges, a 3-dimensional photonic crystal that cancels every wavelength of light except that brilliant electric blue. Inspired by this, engineers at Qualcomm created the Mirasol display, a screen that used no backlight at all. It used tiny mirrors to reflect ambient light, making it bright even in direct sunlight, and it used almost no power when the image didn't change. So why isn't it in your phone today? Because nature's designs are perfect for nature's rules. The butterfly's color is static, one perfect shade all the time. But for us, pixels need to move, to show video, games, and endless scrolling. Those moving mirrors drained the battery, and the colors looked dull next to OLED. Nature gave us the idea, but adapting it to our messy human world is another story. Invention number 3. The desert beetle's back. 2/3 of the world's population faces water scarcity. But in one of the driest places on Earth, a beetle drinks the air. Every morning, the Namib desert beetle climbs to the top of a dune, turns its back to the wind, and waits. Its shell is a masterpiece. Tiny bumps that love water sit between channels that hate it. The fog drifting over the dunes condenses only on those bumps. The droplets grow and grow until they roll down the waxy channels straight into the beetle's mouth. Scientists at MIT copied this design using a mesh patterned with the same contrast, hydrophilic and hydrophobic regions side by side. The result? Large fog nets that can capture up to 1 liter of fresh water per square meter per day. A beetle's back turned into a human water machine. Now let's talk about process. Nobody likes a needle. It's a crude design, a century-old nail shoved into skin. But the mosquito, it's a surgeon. Its proboscis is a 4-part masterpiece. First, it injects an anesthetic, numbing the area. Then 2 tiny serrated blades flank the central tube. They vibrate, not push, slicing gently through the skin. And at the tip, it's soft and flexible, so it deforms tissue less and activates fewer nerves. Researchers found the mosquito's bite requires 1,000 times less force than our best medical needles. Now, engineers are building microneedles that copy this principle, vibrating, flexible, and nearly painless. Our most annoying insect might just be the key to painless medicine. Finally, system. Our buildings are energy hogs. We design sealed glass boxes and then spend fortunes cooling and heating them, fighting nature at every turn. Termites do the opposite. Their mounds are breathing ecosystems, self-ventilating, self-cooling homes for millions of insects and the fungi they farm. For years, scientists thought we knew how they worked. We didn't. The Harvard team discovered that a termite mound is like a giant lung. During the day, sunlight heats its outer flutes. The warm air inside rises, pulling cool air from the tunnels below. At night, the air reverses. Cool air sinks in, flushing out CO2 and storing coolness in the mound's thick walls. In Harare, Zimbabwe, architect Mick Pierce copied this system for the Eastgate Center, a huge office complex that breathes naturally. At night, cool air is pulled in and stored in its concrete bones. During the day, that cool slowly releases and warm air drifts upward and out through 48 chimneys. The result? Eastgate uses 90% less energy for ventilation than similar buildings and cost 10% less to build. It doesn't fight the climate, it works with it. Conclusion. From thief to student. A light that's 55% more efficient. A needle that's 1,000 times gentler. A building that breathes with nature. And water pulled from thin air. All thanks to insects. And we've barely begun. Scientists are studying slug mucus for surgical glue, butterfly wings for better solar panels, and spider silk for ultra-strong, flexible materials. Biomimicry is not just a design philosophy, it's a survival strategy. Because the old industrial model of heat, beat, and treat is running out of road. Nature's model, elegant, sustainable, and time-tested, is the future. So no, we didn't steal these inventions. We're finally learning. We're moving from thieves to students, and realizing that the greatest engineers on Earth have 6 legs.